here, and I'll do the first one, I'll answer the first two parts without a calculator, and then we'll graph the function on the calculator to graph it. Okay, so this is our function here, and the first part says, find the asymptotes and discuss behaviour near them. So just notice the first three dot points there, and I should, I suppose, talk about what a rational function is. It's when we have one function divided by another function. Okay, we've been doing these in calculus. In order to differentiate that, we have to use the quotient of one function divided by another function. That's a rational function. All right, we've got the roots occur when the top is 0. It's undefined when the denominator is 0. There's a horizontal asymptote when the denominator is 0. Vertical asymptote. And there may be a horizontal asymptote, and we need to investigate to determine where. All right, so let's answer the question. Here's the graph. Find the asymptotes and discuss the behaviour here. Well, firstly, there's going to be a vertical asymptote. Vertical asymptote when the denominator is 0. When x take 5 is 0, x equals 5. Alright, so we've got a vertical asymptote. There's going to be a horizontal asymptote as well. Alright, and so in order to figure that out, we've got to go to the extremes of the Cartesian plane. Let's make that argument again. What happens as x approaches positive infinity? Okay, as x gets really large. So just think about a large number. 1,000 is large enough. If you put 1,000 in here, okay, and 1,000 here, what you basically got is 2 times, or even let's just put infinity, 2 times infinity plus 3 on infinity take 5. Alright? Because these numbers are so large, alright, this is not having an impact at all because there's no variable associated with it. So if you have 2 infinity divided by infinity, it simplifies to 2. Alright, as x approaches positive infinity, y, the function, approaches 2. It's getting closer and closer and closer to 2. Alright, and you'll see the exact same from the negative side as well. If we put negative infinity here and here, we've got a negative divided by negative, so it will be positive. But you'll see the same effect. So therefore, we have a horizontal asymptote at y equals 2. And we can observe that from the graph. We'll look at that in a moment. Okay? Next part says, find the axis intercepts. Alright, so firstly, let's do the y-intercept. Y-intercept occurs when x is 0. So if we put x is 0 in here, we're going to have y equals 3 on minus 5. Alright, negative 3 on 5, that's the y-intercept, negative 0.6. And the x-intercept occurs when y is 0. Alright, so let's do that. 1, x, y is 0. So we're going to have 0 equals 2x plus 3 on x take 5. So therefore 2x plus 3 is 0. X is negative 3 on 0. Alright, so we've got the axes intercepts. Now to answer the question, I think we should write y-intercept and x-intercept. That's nice and clear. Okay, and then lastly, graph the function. So let's use our calculator to support us here. We can see where the asymptotes are. We know where the x and y-intercepts are. Like, that's enough to plot some points on there. So you know what's going through those points. But use your calculator to support you. So we've got 2x plus 3 on top of x subtract 5. Still one of these ones. Got passing through here. There's that vertical asymptote, horizontal asymptote. X. And you may need to zoom out a bit more to see it properly. Yep. Okay. And so then you're going to need to label all that stuff. This is 5. This x equals 5. This is y equals 2. Label the function. Got the shape right. Put the x-intercept and y-intercept on there that we found. That's 1.5. That's 1.5. minus 0.6. I'll clear a bit of space for the next question while you guys finish off that one. I'm going to rotate. Alright, so let's go for x squared, take 2x, take 3, and I imagine it asks us to do the same things. So question 2 there, find the asymptotes and discuss the behaviour near them, so what's happening. So firstly, we have, let's use the graph to help us out here. Well, we obviously have a vertical asymptote at minus 2. And so what we can see is it's shooting up on the right hand side and then shooting down on the left hand side. We can also see, I might just do a quick sketch of the graph so I can talk about it as I'm pointing at it. At minus 2, so that's there. We have this sort of minimum point here. And we have this maximum point here. And what you can see is they, I haven't drawn it very well, but they seem to follow the same line. Okay? Not that that's an asymptote. Alright, not that that's an asymptote. That's necessary for us to label the domain and range. But yeah, it's an interesting piece of information. Okay, so then we've got find the asymptote. So that's the only asymptote we're interested in, okay? Because it's not restricting the range. If we were to answer the range, we're going to say, well, y is less than that value and y is greater than that value. Okay? If we're going to say the domain, that's the only restriction on x. So we can answer both of them without considering what's going on there. Next, find the axes intercepts. Okay, so for the y-intercept, that's going to be minus 3 and 2. That's what that point is. And then the x-intercept, we've got 2 of them, occurs when the top equals 0. Minus 1 and positive 3. All the information we need to put on the graph. Splendid. So that's enough to get through D and E. Let's see how we go.